You know, when you're wading through just the sheer amount of information that's out there today, really getting a grip on the basics, the foundations of different kinds of knowledge, it can feel a bit like trying to find your footing in thick fog.
It really can.
Yeah.
You've got data coming at you constantly, opinions presented as facts. Sorting it all out to get a real solid understanding is tough.
And that's pretty much what we're aiming for here on the deep dive.
Exactly. Think of us as, well, guides, maybe.
Yeah.
We sift through the material you give us, pull out the core ideas, the connections, those kind of aha moments.
Right. So you get that genuine grasp without feeling like you've just, I don't know, wrestled a super dense textbook.
Precisely. We want you to feel informed, quickly but thoroughly.
So today, we're diving into something really fundamental to how we understand the world, the different kinds of science.
Yeah, based on the material you sent over Chapter 9 of Professional Generalism. It lays out this really interesting idea of a spectrum, exact, hybrid, and inexact sciences.
Exactly. So our mission for this deep dive, unpack these categories for you.
Look at their characteristics, their strengths, their limitations too, importantly.
And hopefully give you a clearer framework for seeing how they all kind of fit together to shape what we know about, well, everything, really.
Couldn't have said it better. Let's get into it.
Okay, so this spectrum idea. The first thing that really struck me from the chapter is that it's not like, neat separate boxes. Exact science here, inexact over there.
No, not at all. It's much more like a gradient, a sliding scale, moving from the very exact through this middle ground they call hybrid, and then towards the inexact end.
And what determines where something falls on that scale?
Well, the key thing, according to the source, is how consistently and clearly you can observe and define whatever it is you're measuring.
Okay.
Think about it. If you can measure something, and pretty much anyone, anywhere, anytime would measure it the same way because it's directly observable, that's heading towards the exact end.
That makes a lot of sense. And the chapter also points out that even the hard sciences, the exact ones, aren't totally clear-cut, right?
Exactly. They mention quantum mechanics, for instance. There's inherent uncertainty built right in.
And on the flip side, social sciences, which we might think of as less exact, can definitely use very rigorous quantitative methods.
Right. And this leads to an interesting point they make about social science research.
Which is?
Well, if social scientists are studying things we can physically observe and measure consistently, like, say, years of schooling from records and time spent playing sports from observation, then that type of study, if the context is similar, could actually fall under the umbrella of exact science.
Huh. That's fascinating. So it's less about the overall field and more about the specific thing being measured and how.
Precisely. But, and this is a big but, the text highlights just because something uses methods from exact science doesn't automatically mean the results are super valid or reliable.
Right. That makes sense. You still need good research design.
Absolutely critical. Things like sample size, controlling for other factors, confounding variables. That applies everywhere, across the whole spectrum. Good design is paramount.
Okay, so let's shift to the other end then. Inexact sciences.
Right. Here, the source talks about dealing more with immaterial energy, things that aren't physically tangible in the same way.
Like opinions, beliefs, feelings, that sort of thing?
Exactly. Thoughts, intentions. You can't just put them on a scale or point a camera at them directly.
And that obviously brings challenges.
Huge challenges. The chapter lists quite a few, like language itself, how I describe feeling curious, might be totally different from how you describe it.
Interpretation issues.
Big time. And memory out. How accurately do we even recall our own feelings or opinions from last week, let alone longer ago?
Yeah, good point.
Then there's the researcher's influence, however subtle. And people sometimes give answers they think sound better, social desirability.
Or maybe the researcher interprets the answer through their own lens, which might not be what the person meant.
Absolutely. All these factors mean that a study relying mainly on collecting opinions isn't going to qualify as exact science.
Okay. So that brings us to the middle. Hybrid sciences.
Yep, the blend. These might use some directly observable data plus information from things like questionnaires or interviews.
Or sometimes just participant information, but maybe measured in a more structured way.
Could be. And a key point the text makes here is about validity again.
How so?
When these hybrid studies look at that immaterial energy, the clearer the links they can make to actual observable material events or behaviors, the stronger the results tend to be.
Okay, can you give an example?
Sure. They use the example of studying curiosity and risky behaviors.
Right.
If you just ask, how curious are you? On a scale of 1 to 5, Well, what does curious even mean there? It's pretty vague.
Yeah, very subjective. The results wouldn't be very reliable.
Probably not very valid, yeah.
Yeah.
But contrast that with asking something much more specific tied to an action or frequency,
Right.
like the example they give. On average, how often in a single day do you feel an urge to find out more about something beyond the first piece of information you get? Maybe with clear frequency options.
Ah, okay. So you're anchoring the abstract idea curiosity to a more concrete, potentially observable behavior or impulse frequency.
Exactly. More specific definitions, more specific measurement scales that boosts the potential for validity, even for abstract concepts.
Although you're still relying on people remembering accurately and answering honestly.
True. The text acknowledges that. There are always limitations, but specificity helps.
So across all of this, the running theme seems to be validity.
It really is. That's a core message for you, the listener. Better validity comes from clearer definitions.
Stronger links between abstract ideas and things we can actually perceive or measure.
And using more specific, well-defined scales for measurement, that applies whether it's exact, hybrid, or inexact.
And of course, the chapter also touches on ethics.
Crucial point, especially with human participants. Being ethical in how we conduct research and report findings is fundamental. Research ethics codes are there for a reason.
Definitely. Okay, so moving on to scholarly synergies. What's that about?
This ties back to the definitions. The text argues that having clear, agreed-upon definitions and solid measurement tools is especially vital in the inexact sciences.
Because the concepts themselves are less tangible to start with.
Precisely. If you're studying, say, well-being or creativity, without grounding it in anything observable or consistently measurable, your findings are just, well, much harder to validate or compare.
Yeah, I can see that. If everyone's using their own slightly different definition of well-being, how can you build knowledge together?
Exactly. It makes it incredibly difficult to build a coherent body of knowledge. The source even suggests that research without these shared robust definitions might struggle to be called science in the strictest sense.
Wow, strong claim.
It is. And it leads to this interesting contrast the chapter draws between how exact sciences often progress versus inexact or hybrid ones.
Okay.
In exact sciences, there's often a stronger tradition of sharing findings openly, building on previous work, agreeing on definitions.
Like the definition of a meter or how scientists collaborated globally on COVID vaccines.
Perfect examples. It's more cumulative, building on a shared foundation.
Whereas in inexact or hybrid fields.
The text suggests there's more of a tendency for researchers to tweak, modify, or even kind of reinvent concepts and methods from earlier work.
Why? Maybe chasing novelty or wanting to make their own mark.
Could be various reasons, and innovation is good, obviously. But this constant reinvention can sometimes get in the way of developing a truly unified understanding.
Makes it harder to build consensus, maybe.
Yeah, and harder to speak with one voice, both to other academics and to the public.
The safety culture example they use really highlights this, doesn't it?
It really does. A term used since Chernobyl in '86, but because it wasn't initially defined based on observing actual behaviors.
There's just been decades of debate about what it really means, with no single agreed-upon definition.
Exactly. Which isn't to say concepts like safety culture or employee engagement aren't useful. They absolutely are for communication, for getting people on the same page in organizations.
Right, they serve a practical purpose.
Definitely.
Oh.
But the source argues we need to balance that usefulness with a constant push for more rigor.
How?
By using mixed methods, doing longitudinal studies to track things over time, really working hard on clear operational definitions that link the abstract idea to something observable.
Connecting it back to the real world.
Always. And they float this interesting idea. Maybe scholars in these fields should deliberately get together every, say, 5 or 10 years.
To do what?
To thrash out and agree on core definitions for key concepts and then report that consensus back to professionals working in the field.
Huh. Like a standards committee for concepts?
Kind of. It could reduce a lot of confusion that just comes from people using the same word to mean different things. A call for more unity, really.
Interesting idea. Okay, so how do these different types of science actually interact? The chapter says the immaterial often drives the material.
Yeah, that's a really insightful point. The idea is that something like human curiosity, definitely immaterial, right? A thought, a desire. That's often the spark. It generates ideas, which then lead to systematic investigation, discoveries, actual tangible inventions in the material world.
So our inner world kicks things off.
Often, yes. Think about engineers. They rely heavily on exact science for design, measurement, building things.
Of course.
But their job also involved tons of less exact stuff, collaborating with teams, understanding client needs, persuading people to fund their projects. It's a mix.
And it goes the other way too, right? Exact sciences sometimes invent abstract ideas.
Absolutely. When exact science encounters things it can't directly observe or measure yet, it develops theoretical constructs. Think about the Big Bang Theory or dark matter trying to explain the observations.
Right. The chapter uses the example of stomach pain in medicine to show this interplay really well.
Yeah, that's a great illustration. It usually starts with the patient describing their feeling totally subjective, inexact.
The doctor can't see the pain itself?
Nope. So diagnosis begins in that inexact realm. The patient might not describe it perfectly. The symptoms could mean many things.
It's information gathering, not hard data at that point.
Exactly. But then the medical team brings in the exact science tests, scans, imaging.
To pinpoint the physical cause, ideally, neuroscience can even explain the pain pathways very precisely now.
Right. And this is the profound part the source emphasizes. Imagine if we didn't have the concept of pain in our minds.
If we just ignored bad sensations.
Or if we lacked empathy, that desire to help someone else who's suffering, would we even bother applying all that exact science to understand and treat it?
Probably not. So the immaterial drive, feeling pain, wanting relief, caring for others, actually fuels the exact scientific investigation.
That's the argument. And even once you have a diagnosis and treatment, things like the patient's trust, their mindset, those inexact factors can really impact how well the treatment works.
So it starts and ends with the immaterial in a way.
In many ways, yes. Which leads nicely into thinking about the different roles these sciences play.
Okay, so exact sciences are great at
Showing observable cause and effect.
Yeah.
If I do X, Y happens and I can measure it.
and hybrid and inexact sciences.
They're more focused on explanation and interpretation, especially for things we can't directly perceive, and how those things interact with the material world.
And importantly, the text says understanding physical causes doesn't mean immaterial factors don't matter.
Exactly. And just because immaterial energy is hard to study with exact methods doesn't mean physical causes aren't real. They're not mutually exclusive.
What's seen as the primary role of the immaterial sciences, then?
The source suggests it's really about raising societal awareness, shaping how we collectively understand issues. Their influence is broad, touching all kinds of activities and products, even tech, driven by exact science.
And inexact and hybrid help us reflect.
Yes, reflect on why we use material energy the way we do, what factors are driving us. They study the nature of immaterial energy, often through interdisciplinary work.
And the text also says, just because exact science hasn't explained something yet.
Doesn't mean it's impossible. Inexact and hybrid sciences can offer clues, indications, even if not definitive proof in the same way.
And maybe the most powerful role mentioned, guardians of humanity.
Yeah, that's a strong phrase. The idea is they provide an ethical check, especially if exact science applications might go off track ethically. Ethics itself largely comes from inexact inquiry philosophy, humanities,
So they provide a balance.
a vital counterbalance. Countering pure deduction with induction, adding the big picture view to the minute details, suggesting system improvement instead of just rejecting flawed parts.
The pain management example fits here again, doesn't it?
Perfectly. The shift from just seeing pain as a mechanical fault to understanding the whole person, cultural, psychological, social factors that came largely from humanities and social sciences influencing medicine.
Makes sense. The text also notes that exact sciences get more scrutiny.
Well, yeah, because they deal with tangible stuff. We expect their results to be testable, verifiable, reproducible in a way that's harder for interpretations.
And there's that point about critics.
Right. People might criticize designers using exact science if things aren't perfect, but the critics often don't have their own tangible, tested alternatives ready to go.
So the goal isn't to say one type is better.
Not at all. It's about understanding how they can help each other, inform each other, while respecting their different approaches.
Like engineering, based on exact science, changes our environment, which changes behavior.
And humanities, more inexact, influence people who then change the environment.
And management, maybe hybrid, allocates resources and influences motivation, that immaterial energy.
Exactly. It's all connected.
The source also makes that distinction between observable acts data, evidence,
And our thoughts or interpretations about those acts information, meaning it's easier to agree on what we saw happen than what it meant.
right, and even in exact science experiments designed for clear cause effect.
Designing the experiment, running it, analyzing the data, all involve interpretation, which is fundamentally an inexact process itself.
That's a subtle but important point. And finally, that idea about judgment.
Yeah, that we aren't usually judged for our inner thoughts or feelings, our immaterial energy.
But we are judged when those manifest as observable actions based on society's rules and interpretations.
Uh, but the good news, the text concludes, is that we're seeing more collaboration.
Professionals realizing the limits of being too specialized.
Exactly. Embracing multi-transdisciplinary approaches. The different scientific families are working together more.
So to kind of wrap up the core idea, they offer a simple framework.
Yeah, the helpful summary. Exact sciences show cause and effect. Hybrid sciences explain them. Inexact sciences interpret them.
Show, explain, interpret.
Nice.
And a little piece of advice comes with that framework.
Which is,
Be a bit wary of anyone claiming they have all the answers based only on one category.
like the purely exact person who thinks data fixes everything.
Or the purely inexact person who claims to perfectly understand everyone's inner world.
Or the hybrid person who thinks they can explain absolutely everything completely. Right. Reality is usually more complex, needing insights from across the spectrum.
So understanding this whole spectrum, these different ways of knowing, is really valuable for anyone trying to be well-informed today.
Absolutely. It helps you navigate that information fog we started with.
Yeah. The key takeaways for me are really seeing how interconnected these approaches are.
Recognizing their different roles, but also their limits.
And just appreciating that knowledge comes from observing, yes, but also from explaining and interpreting. It's all part of the picture.
Couldn't agree more.
So maybe a final thought for our listeners to mull over.
Go for it.
Thinking about this framework, exact, hybrid, inexact, how might it apply in your own field or areas you're interested in?
Ooh, good question.
Are there times when maybe you or others in your field lean too heavily on just one type of evidence, just the hard numbers, or just the interpretations, and maybe miss a bigger, more complete picture?
That's definitely something to eye on. Thinking about where the balance lies and where different perspectives could enrich understanding.
Exactly, because getting a handle on these distinctions, it really can lead to, well, more nuanced thinking.
Right. And just a deeper appreciation for all the different ways we figure things out about the world.
Well, thanks for taking this deep dive with us today.